Welcome back to part 2 of our video for multiplication tips and tricks. We, in the last video, covered partitioning, we covered compensation, doubling and halving as well. So in this video, what we're going to do is we're going to have a look at multiplication by factors, which is something I don't see taught very often, grid method and column method, which some of you may already know. So let's get started. So this technique is really helpful, but does require you to actually know how to find factors of numbers. I'll do another video on factor bugs and factors. It's really useful to understand how numbers are made. But let's go ahead and look at an example here. 3 times 8. Nice and simple. Now, many of you will be able to go ahead and do that straight away and tell us the answer. For some of you, the 8 times table might not be your favourite. So instinctively, you might want to do something slightly different to help. What we can do is we can write, well, factors of 3. 3 is a prime number, are 1 and 3. However, the factors of 8, I can see 2 simpler factors. We can represent this. Instead of as 8, we can write it as 4 and 2. 4 times 2. Here, you know, 3 times 4 is 12. And if we've got to times it by 2, that takes us to 24. And you might, in this instance, not see the value of this technique, but I guarantee you already use this. Let's try something slightly different. Let's have a look at 3 times 300. And you're thinking, well, I don't need to know the factors of this. I can just go ahead and do that. Well, let's be honest. What most people tend to do is they say, well, let's do 3 times 3 and then times it by 100. You might hear me say, put the zeros on the end. There's 2 zeros, just pop them on the end. What we're really doing here is breaking it up into factors and seeing 9 times 100 and coming to our answer of 900. We might also use it in other examples with numbers that end in 0. For example, 40 times 8 is, we're going to look at this as 4 times 8 times by 10. You say 32 times 10 is 320. You're likely already doing these tricks in your head. The only thing is you're doing them so quick you don't realize you're doing them. But if we focus on what we're actually doing, we can go ahead and expand that to other calculations. Another example I'm going to give you is actually, here we go, 7 times 9. You might want to go ahead and do 7 times 3 times 3. This here, 7 times 3, 21. And times this by 3. This here is going to be 3 times 20 is going to be 60. 3 times 1 is 63. There we go. Now I do have some example questions for you as well that are going to come up now. So here we go, guys. We've got a couple of example questions. I think you can tell that the example questions are actually, the questions that for you to try the exercise is harder than the example questions. And the reason being is I wanted you to get an understanding of what we're doing here, but actually applying the technique and finding the factors of these numbers is what's really going to help you. And these two down here are quite tricky. They do require some partitioning. And it helps if you actually know your cube numbers and square numbers as well. But I'm going to let you have a go, and we're going to come back and I'm going to show you how I would have broken each one down and multiplied them, and then we can go from there. 3, 2, 1. So before I show you guys the answers, I just did want to mention real quick that if you're finding this difficult, don't beat yourself up. It's all about playing with numbers, and the more practice you have, the more proficient you will become with this exercise. Okay, so have another go or move on to the next question if you're struggling. If not, the answers will be shown in 3, 2, and 1. So here's my calculations. Pause the video now if you don't want to see the answers. Here I've used, you started off with 3.5. If you look at one of the last videos, we did double and halving. Essentially, that's what I've done here, is I've doubled this and halved this number. But then I realized I can halve it again, square it and double it. And that comes to 98. Here, this is pretty clear cut. If you times into 25 by any number that has a factor of 4, you want to times that by 4, divide that number by 4, so you get something like this, 4 times 100. Here, you might say, well, 81 times 4 is still hard. I understand, but, unless you're using compensation, it's not going to be as hard as 9 times 36. Because 1 times anything is going to be that number. So this is essentially 80 times 4, which is 320, and 4. And really, you probably actually wouldn't need to go ahead and do this in 2 steps. You could probably go ahead and do this in your head. Here's another one that uses partitioning, 3 times 100. And 3 times 8. Again, here we have 9 times 12, but I did say at the beginning of the video that this assumes that you know your 12 times tables. Getting down here, it's a little bit more difficult now, and this is what I was on about with your cube numbers. If you can do 5 times 25, hopefully you guys know that's 125, and I would go ahead and just partition here anyway. So I could do this as 900. I could do 9 times 20. You can break this down, fully break this down. 9 times 20 is 180. And 9 times 5 is going to be 45. Okay. Alternatively, what you could have done is you could have done 9 times 25. 8 times 25 is 200. So we could have just said, let's pop another 25 on top of that and write this as 225 in one go. We've got a 1 to carry, so that's 10. That means I've got another one there. 1,125. Okay, over here, 5 times 7 times 3 times 5. And what I've done is just took the 2 5s, times them together to give me 25 times 7 times 3. You might think, this isn't all that easy to do in one go. Well, that's why I've placed the 3 at the end, because if I multiply up to a bigger number and then need to, it's easier to times a bigger number by a smaller number than it is for me to times something like 75, 25 times 3, 75, and times that by 7. So if I make the number bigger first and say the last multiplication to be a small number, that helps me out. And here, just go ahead and partition. 100 times 3 is going to be 300. 75 times 3, I would just double 75 to be 150, add 75 on top of that, and here we are at 225. With our answer of 525. Hopefully you got some of these right. I really do recommend you just play around with them. You might not get it in one go. This is a fantastic technique. It's going to help you in so many ways, but play around with this and actually go ahead and try and write a question. Write questions for these. If you could write just 3 questions for these, it gives you more of an understanding as how this is. So imagine you wanted to give your friend some questions, make them 2 medium questions and 1 tricky question, and see it will develop your understanding of how this technique works. Next, we're off to grid method. So here we grid method. It's best to use it for multiplying 2 digits by 2 digits or bigger. If you're going to do 2 digits by 1 digits, you're basically doing partitioning with extra steps. So let's go ahead and show you what this grid method is. Well, we've broken down our calculations. So we've got 39, we've split that into 30 and 9, and we've got 12 into 10 and 2. And all we're just going to go ahead and do is create a grid. So it's up to you how much space you want to use for these. I'm just being space conscious of the board. So let's start there and I'll build upon this as we go along. Okay, let's do 30 times 10, 300, 30 times 2, 60, 3 times 9, 90, 9 times 2, 18. Okay, fab. Right, I'll explain more why, but it is best to add our numbers. I'll explain more why later, but it is best to add our numbers up here on the right hand side. So let's go ahead and extend our grid. You might want to do this all in one go at the beginning, but I feel if I draw it all up at the beginning, it gets a little bit intimidating, so I just add it on as I go along. Add these two up, 360. Add these two up, it's going to be 108. Now here we can add these up using column addition. It's a little bit easier. That's why I like to line them up in the columns here. 8, 6, and 4. Our answer is 468. So go ahead and draw yourself a grid now. Pause the video. So here, this is what it looks like if you go ahead and draw the grid beforehand. As I mentioned, if you don't know where this is going, this could be a little bit intimidating. I would also note, this feels like I made this line a little bit too small, so please try and make especially the first column a little bit wider if you can. Right, let's go ahead and do the calculations. 4 times 5 is 20, and we've got these two zeros to put on the end. 50 times 7 is going to be 350. See, if I make the column smaller, it's hard to keep the numbers in each column, right? Because this, naturally, I'm going to crump up this number and I'm going to write this number freely. 4 times 6 is 24, 0 on the end is 240. 6 times 7, 42. Now, let's go ahead and add these up. I'll give you a second to pause. Okay, let's go ahead and have a look. So add these up, 2,240, add these up, 392. So now we just tally in this column is a 2. Here, 9 and 4, going to leave us with a 1. We're going to carry 1. That's going to be 3 and 6. And then the 2, we should put it in front. But 2,000, I've counted wrong. Whoops. 9 and 4 isn't 11. I've just realised that. So do check your calculations. 9 and 4 is 13. So it's 2,632. Now if you have something slightly different in these columns, it might be because you've got 56 here and 47 here. So here I've just quickly gone ahead and shown you what it might look like if you guys ordered the numbers in a different way. You still get the same answer, 2,632. At this point, you might be saying, look, I don't really get the whole point of this partitioning stuff. This grid method. I'm just going to go ahead and partition because I liked that last video. I just want to mention that sometimes there are limitations to partitioning, hence why this panel is called Partition Fail. I'm going to lay it out for you and show you how in this instance grid method is actually better than partitioning. This is even still a good method for 2-digit times 2 digits if you're not comfortable with multiplying or you feel like your multiplication skills aren't that strong. I used to be a massive fan of grid method. The reason was simply that yes, I had to do more work, but it was less to do in each step. So more steps, but less to do. And it really broke it down and it started to help me build confidence in being able to do more difficult multiplications. So here I'm going to break down my partitioning and show you what it would look like. If anyone's brave enough to practice their partitioning, you can do so. And I'm going to pause the video. I'm going to skip to the show my calculations in 3, 2, 1. So first off, what we can actually see is that we've got a lot more adding to do. So over here, this was slightly easier because we've already done some adding. Now we have to add 4 digits. Still very doable. So 5, 9 and 4, which is going to be 13. 6 and 2. So yeah, same answer as before. So yeah, you could say partitioning works here, and you might say this is less than doing the grids, but let's have a look at what we've got down here. This is a little bit messier now because we've got 6 different multiplications written out, 6 different answers, and we need to add them. So let's start with the units column. 8, 3, 6, 9. This is going to be 10. Carry the 1. So that's 2, add 6 is 8. Oh, another 10. Okay, 2 and 2 is 4. These 2 ones as well, so that's going to be 6 in total, and leaves us with 4. Okay, so that's 46,008. And to write this out, it just takes quite a bit of time, and it might be easier to do using grid method. So here we've got some more example questions of grid method. Here you can see when I'm doing a 3 and 2 digit number, the same calculation, it just makes a little bit more sense to use the grid method. Instead of adding up 6 different numbers here, now I just add up 3. Again, I keep my columns nice and neat, and it comes in even more use when we do a 3 digit number times a 4 digit number. But yeah, this is a lot easier to add here. We'll put 1 there, put a 0 for this column, move on to the next column. It's the same calculation. Okay, so clearly I should have made my box a little bit bigger there. So now with this one, this is where it really starts to make sense, and I just want to point out a few things. One, you can see this first column is quite wide because I know 1, 2, 3 zeros here, 1, 2 zeros there. This is going to be quite a big number, and in fact it's probably not wide enough, that column. Again, same over here. This is going to be quite a wide column because it's going to be all these numbers added up, and even this one is going to have a 4 digit number in it. Also, I want to point out that I've broken down my number with the largest digits this way, and the reason I have done that is simply because what it allows me to do is to move down with these calculations, and then as I go along I have less to count up. So now I have 3 additions to do instead of 4 additions to do going across, and I come to my last column here, and then I can use column addition to add up four different numbers. So pause the video now and go ahead and get it filled in. I'll be showing my answers in 3, 2, 1. So as you can see, I've had to make some of my columns wider, and that is just to fit this 1.2 million number in here, 1,200,000. So we're playing with some really, really big digits here, but I wanted you to see my multiplication calculations before you see me add everything up. So I'm really, really glad that I didn't put a final line here for the addition. It allowed me to write my numbers a little bit more freely, and that's super important because if I'm doing column addition, I want to make sure everything's in the right column and not squished up. Here you can see this method is much easier than partitioning, because if I was partitioning, I would now have to add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 numbers in column addition is a lot. Even 4 can be challenging sometimes, or 5 can be challenging sometimes. Here I've got nothing but 6, nothing in the tens column but 6. 4 and 7 is 11, so put 1 here, carry the 1. And then we can come up here, 8 and 4 is 12, add 3, 15, add 6 is 21. This one makes it 22. So pop a 2 down here, carry 2 over. 4 and 3 is 7, add the 2, 9. 3 and 4 is 7, and we bring that 1 down. So that is quite a complicated version of grid method, and hopefully you don't have to do many 3-digit times 4-digit numbers, and my exercise questions that I'm about to bring up will not be this complicated. But it's good for you to get an understanding of how this method works and how it can be useful for more challenging calculations. Okay, so here's some practice questions that I want you to have a go at, and then I'll be showcasing the answers shortly. But a couple of things I want you to keep in mind. This is a 2-digit and 2-digit one, and these are both 2-digit by 2-digit numbers, so this should be fairly easy. This here you'll start to see how useful grid method is, and this one here can be a little bit challenging. But guys, when you do these two, please make sure your 3 digits are laid out vertically and your 4 digits are laid out vertically. This allows you to make the most of column addition at the end. So I'll be showcasing some answers in 3, 2, 1. So here you guys have an opportunity to go ahead and check your multiplications before we do any addition work. And obviously here with these you can actually really start to tell the effectiveness of putting the 4-digit number here on the side instead of on the top, because now you've got 4 numbers to do in column addition, now you need 2 to do side by side. So 3, 2, 1. So thankfully we can see here with our addition there's not actually been too much carrying over. So hopefully we've all got the same answers: 768, 2160, 17,172, and down here 167,238. So that's the grid method. I think it's really useful for gaining confidence in multiplications. It's really useful for doing tricky things like this as well, that are just quite hard to lay out otherwise. However, it does take a while to build the grids. It is very structured and rigid. That's why I feel like this is a good place to start, and then evolve your practices to partitioning for more complicated calculations. But this definitely has a benefit. Introduce this if you haven't got a lot of confidence in multiplying 2- and 3-digit numbers, because it breaks everything down, allows you to add it up step by step. Remember, first we want to get it done correctly, and then we want to pick up our speed. But don't worry about speed until we are getting proficient and comfortable with multiplying. So let's look at column multiplication now. This method seems to be a little bit more procedural, and it's less about knowing the value of each number and more about carrying out a process. And you'll understand that process. The best way for me to explain it is just to do it. So let's start with the units column here. 3 times 4 is going to be 12. I'll put a 2 down here, and I carry 1 over to here. And this is kind of what I think people get confused by, is all the carrying in this method. Once you get good at this method, it's something that hopefully you find easy to do. So we take the 2, so over here now we do 3 times 10, or 3 times 1, sorry, and that's going to be 3, and then we carry this one here, so it's 4. So once we're done with this, we can put a cross through it, and we do, here we're doing 20, but because it's written 2, we're just going to fill this space here with a 0. 2 times 4 is going to be 8. 2 times 1 is going to be 2. And now we can just go ahead and add everything up. And we have an answer, 322. So if you want to have a go at some of the others, you can pause at any point throughout this explanation and go ahead and try them. But for now, I'm going to keep going. So 8 times 3 is going to be 24, carry the 2. 8 times 4 is going to be 32. So I'm going to do 2 add 2, and that's 4. I'm carrying the 3, put the 3 here. So this is kind of the reason why I'm not a big fan of this method. It's because you're having to remember numbers whilst focusing on something else. It can be a little bit taxing, so maybe jot that down first. And we put that there. Great. So 6 times 3, remember we've got to fill this space here with a 0. 6 times 3 is going to be 18. We carry, let's cross these out. We carry the 1 over here. 6 times 4 is going to be 24. 4 and 1 is 5. Carry the 2. There we go. Now we can go ahead and add these up. This is going to be 9. There we go. And we have 2,924. 0 times 7 is 0. 5 times 7 is going to be 35. 2 times 7 is going to be 14. Write that 1 there, pop that down first. 4 and 3 is going to be 7. Okay, now again fill this space up because we want the tens column. 0 times 1 is going to be 0. 5 times 1 is going to be 5, and we have a 2 here. Lovely. Now we can go ahead and add these up. And we have 4,250. Lastly, 2 times 5 is going to be 10. 2 times 7 is going to be 14. Carry that. There we go. Again, I'm having to add 4 and 1, which is quite easy, whilst holding this in my head. And then go ahead and do 2 times 3. There we go. Now pop a 0 in this column, remember, because we're doing 40, not 4. But we're going to, for simplification, to simplify things, we're going to be doing 4 times 5. So that's another 0, and we need to carry a 2. 4 times 7, which is going to be 28. So carry a 2 further. The 2 and the 8 becomes a 0, so actually carry 1 more. And then 4 times 3 is going to be 12, but we already have 3 here, so let's just write 15,000. Okay, once we add these up, we can see that it's 1,000. So it's 15,650. And just a common sense look here actually tells me that, hang on a minute, I've made a mistake. And the reason being is 350 times 2 would be at least 700. Well, 350 times 2 is 700. How's a number bigger than 350, less than 700? What I've done is I forgot to carry the 1 somewhere. This here should be a 7. Which means this number here would be a 7. It's not something I did on purpose. It's just an example of how I personally find this method a little bit confusing. Okay, so go ahead and jot these down. This is an exercise for you. You can have a go at practicing these calculations. And these are all these 3 are 2-digit by 2-digit. Then we move on to 3-digit and 2-digit numbers. So they get a little bit trickier. So if you go ahead, I'm going to pop some working out on here in 3, 2, 1. So hopefully you've been able to do the multiplications. I haven't done my last tally up yet, so I'll be totaling those numbers in a second. But here, this is one example where I only worked out 1 and then just moved everything across. Some numbers, like number 2, required a lot more carrying. I do think it can still be confusing, but just check your work here before we do the final reveal. We'll do that in 3, 2, 1. Okay, and there we have it, guys. There are our answers. First one is 665. Second one is 1,392. Number 3 is 6,468. Number 4 is 10,080. And if we have a look at number 5 over here, it's 58,368. You can see I've added these commas in later, just help me read and identify the numbers. So I'm hoping you all got lots out of that. Today in this session, part 2, we've covered multiplication by factors, we've covered the grid method, and we've covered the column method here. And this was just outlay all these examples. It's like a full lesson. This isn't a one-hit thing. This is here to be revisited, try it again, take screenshots, because I understand that it's quite long videos, so I would have just took screenshots throughout. And then you've got that to hand. You don't always need to access the video. You can keep them on your phone or your PC device and be able to use them from there. Guys, if you have enjoyed this, I would really appreciate a like and a subscribe and all that. If you can leave comments below, do so. Let me know what works or where you'd like to see more videos. I definitely think I might do another one on partitioning and another one on multiplication by factors, because this is all about playing around with numbers. And there's so much here that I don't feel like I covered it all. But you've got enough of all the other methods. So hopefully you understood that, and have a good day.